Hi, this is Jadip Sai, and the topic which I have selected for this Tech Talk video is exploratory metamorphic testing for scientific software. Abstract. Scientific model developers are able to verify and validate their software via metamorphic testing, even when the expected output of a given test case is not readily available. The tenet is to check whether certain relations hold among the expected outputs of multiple related inputs. Contemporary approaches require the relations to be defined before tests. So the scientific model developers are able to verify and validate their software via metamorphic testing. So the software can be verified and validated by using metamorphic testing, even when the expected output of a given test case is not readily available. So if the expected output is also not available, then also the verification and validation of the software can be done by using metamorphic testing. The tenet is to check whether certain relations hold among the expected outputs of multiple related inputs. So the multiple outputs are compared with multiple related inputs. In this metamorphic testing, contemporary approaches require the relations to be defined for tests. Introduction. So let's discuss the introduction part. Testing scientific software is important because scientific simulations support critical decision making in many fields. For example, because nuclear weapons cannot be field tested, the code is used to determine the impact of modifications in nuclear weapon simulations. Advances are made to help the scientific simulations team to run the tests with command line input and control to check code modifications before contributing changes and to test the science specific programming environments like MATLAB. So testing scientific software is important because scientific simulations support critical decision making. So scientific simulations support the critical decision making in many fields. For example, in the nuclear weapons, the testing cannot be done in the fields by throwing the nuclear weapons in the field because it may damage very large part of the area. So the code is used to determine the impact of modifications in nuclear weapon simulations. So if any changes are made in the nuclear weapons, then the code are generated to calculate how much impact can be done in that area by using these techniques. Advances are made to help the scientific simulations team to run the tests with command line input and control. So advances are made in scientific simulations. Simulations are done by imagining and expecting or predicting the values by using the command line inputs and control to check code modifications before contributing changes. So before contributing any changes or making any changes, the modifications of the code which are newly done are checked and to test the specific programming environments like MATLAB. So also the environments such as MATLAB are also tested. For scientific model developers, the Oracle problem remains a challenge for software testing, and Oracle refers to mechanism for checking whether the program under test produces the expected output when executed using a set of test cases. Due to reasons like the approximations involved in simulation models, Oracle may not be available. So for scientific model developers, the Oracle problem remains a challenge for software testing. So Oracle is a biggest challenge for the software testing because an Oracle refers to mechanism of checking whether the program under test produces the expected output when executed using a set of test cases. So when the set of test cases are used for checking whether the output is matched with the expected output, this mechanism is done by using the oracle. So the oracle problem remains a challenge for software testing due to reasons like the approximations involved in simulation models. Oracle may not be available. So in the simulation models, we are using the approximations. So here the oracle cannot be available. Researchers have applied MT to test scientific software. As summarized in the sidebar, contemporary approaches require the metamorphic relations to be defined a priori. In other words, source and follow-up tests are executed only after a relation is determined, because that relation is used both to guide the test case generation and to analyze the test case execution results. So researchers have applied MT to test scientific software. So in the testing of scientific softwares, the researchers have used the MT, which is a technique. As summarized in the sidebar, contemporary approaches require metamorphic relations to be defined a priori. So before making any tests on the scientific software, metamorphic relations are to be defined first. In other words, source and follow-up test cases are executed only after relation is determined. So only the source tests and follow-up tests are done only after the relation is determined in the scientific software, because that relation is used both to guide the test case generation and to analyze the test execution results. In our ongoing work of developing and testing software integration solutions, we realized that determining a relatively complete set of metamorphic relations without running some tests was difficult. We therefore proposed to develop a hierarchy of metamorphic relations with new related formula based on testing results of previous round of MT. So this is the work which has been done, that is proposed to develop a hierarchy of metamorphic relations with new relations formulated based on testing results of previous round of MT. So based on the previous rounds of testing of the MT, new relations are formulated. Integration of SWMM and PEST. The United States Environmental Protection Agency Stormwater Management Model is a dynamic rainfall runoff simulation model that computes runoff quantity and quality from primarily urban areas. Thousands of studies throughout the world have been carried out by using SWMM, assisting such stakeholders as hydrologists, engineers, and water resources management specialists in the planning, analysis, and design related to stormwater rain runoff, combined and sanitary sewers, and other drainage systems in urban areas. Metamorphic testing for scientific software. Testing is a mainstream approach towards software quality. When the expected output of a test case's execution is not available or is too expensive to be used, metamorphic testing, which is MT in short, can be applied. MT is helpful to scientific model developers because they must address a tower of approximations in their software one, and the software may be written to find answers previously unknown. In a survey covering the papers published from 1990, the year that MT was introduced, to 2015, more than a quarter applications of MT were related to software, scientific software, ranging from numerical programs to simulation and modeling 3. This applicability continues. Specifically, the input file and the observation file in figure 2 are the input data sets of their these integrated software systems. The calibration file, on the other hand, is output data. I thank the faculty and college for providing me this opportunity to speak on the topic. Thank you. Jai Hind.